Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Pickar, again, with a lovely little notes video for Unit 2, Video 1, Functions and Function Notation. What we want you to be able to do is determine whether or not a relation is a function. We'll talk about that, and you can evaluate functions. So first off, presenting relations. A relation can be represented in the following ways. Well, what is relation, first of all? A relation is a set of ordered pairs. It can be written as an equation. I'll just make one up real quick. Y equals 5x squared plus 2, where you're plugging in x values and you're getting out y values. They'd be ordered pairs, so therefore you can write it as an equation also. You can also write relations in the following ways. Basically just a set of ordered pairs. As a table, but these are also ordered pairs. Like here you have the ordered pair negative 2, 2. You could write this as an ordered pair negative 2, comma 2 also, so on and so forth. Graphed, here's a set of ordered pairs. Negative 2, 2 is this point right here. Okay, and then you have all the other points also. Also a mapping. A mapping is this. You take an x value like negative 2. It maps on to negative 2. Negative 2, negative 2. And then negative 2 also maps on to 2, so that's negative 2, positive 2. So you could generate ordered pairs like 0, 1, and then 3, 1. All of these are ordered pairs. They all represent different ways of representing a relation. Okay? On to a function. A function is a special relation. Okay? Where each value or each input has a single output. Now what do we mean by that? Well, input, you're inputting your x values, and that should map onto, your x value maps onto your y value. Your y value is your output. Okay? So here's what we call function notation right here. This is written as a function. It's got an f of x right here, a little arrow coming down to f of x. This is the title or name of our function. Then you got a little arrow coming down to the x in parentheses here. I'm not multiplying the f and the x. The title is f. Your input variable is x. This is just basically got a little line up here. This is function, how it's written in function notation. But little line coming down to the x. The x is your input value. It's the input of the function, we'll say. So whatever you plug in for x, that number would go here, and then it would go into what we call this little bad boy over here, 3x plus 4, which is what we call the rule. The rule, it's used by the function to generate output values. We'll just say generate an output. Okay? This is going to give you your output value, which is equal to the title or the function notation here, f of x. Okay? So a little bit with that. A little bit confusing, but we'll talk about it. Here's our function, f of x equals 3x plus 4. It says using f of x, which is the title of this function. There might be other functions, but we're working with f of x right now. You could have t of x, h of x, g of x, anything, but we're working with f of x. To find and illustrate f of 2 and f of negative 1. So we're going to plug in 2 for x, and then we're going to plug in negative 1 for x, our input variable, using the function machine below. So this is kind of what it looks like. If I want to find f of 2, I'm going to plug 2 in to the rule. Our rule is 3x plus 4. Well, you're plugging that 2 in for x, because that's your input variable. So it's 3 times 2 plus 4. Well, what do you get out? Well, 3 times 2 is 6. 6 plus 4 is 10. So when I plug in 2 through the machine, I get 10 on the outside. Now, you could write it like this. F of 2, when we plug in 2, we get 10. Most of the time they just want, hey, what's your output variable? What's your answer? You'd say 10. But you can also write this as an ordered pair. You're plugging this 2 in for basically your x. So your x value is 2. Your output value is like f of x. F of x is the same thing as y. So you could say y is equal to 10. Some people write it like this. X and y is the same as f of x. That's your output variable. Well, we plugged in 2, and what is f of x equal to? What's my output variable? 10. Okay? So you can write these as ordered pairs also. Okay? Let's find f of negative 1. That means we're going to plug negative 1 into our rule, which is 3x plus 4. So it's going to be 3 times negative 1 plus 4. Well, that's negative 3 plus 4. Your output is 1. So you could say, hey, my answer is 1. Or you could rewrite it like this. You could say, when I plug in negative 1, f of negative 1 equals 1. Or you could write it as an ordered pair. I plugged in negative 1, and my output was positive 1. So like an xy or an x f of x ordered pair. Okay, when a relation is a function, when is a relation a function? Well, one of the ways you can test it is this, the vertical line test. That's where you're given some kind of a graph. I'll just say it's a linear graph right here. And if no vertical line intersects a graph in more than one point, then the graph represents a function. What they're talking about there kind of is this. Let's just take a vertical line. Okay? If it's passing through the graph, there it hits it at one point. If it only hits it at one point, it's what we call a function. Okay? But there's relations that are not functions. So I'm going to give us an example of that. Let's say I'm just going to put an S in here right now. That's a relation. That's a set of ordered pairs. They're all graphed. And as I take my line and run it through it, if I hit it more than one time, it's not a function. Like here, all 3 of these points have the same x value. You can only have one x value per one y value in a function. So this is not a one-to-one correspondence. So not a function. Or this one, because it passed the vertical line test, is a function. Okay? Also, like we don't see a graph here or here. So how do I know if these are functions or not? They're relations. I can see their ordered pairs. But the main thing is this. No x value can repeat. Like I can't have an x value that has can't have 2 x values to 1 y value. It's like here, if you look at ordered pairs. The negative 2 maps onto negative 1. Okay? The negative 1 maps onto 0. The 3 maps onto 0. And the 6 maps onto 4. Okay? This is a one-to-one correspondence because none of the x values here repeat themselves. I have negative 2, negative 1, 3, and 6. There are 2 y values that are the same, but that doesn't matter. This negative 1 only maps onto 0. This 3 only maps onto 0. It doesn't map onto anything else. The x values can't repeat. The y values can repeat. If you looked at your ordered pairs for this table, I have negative 1, 2, 0, 3, and negative 1, 4. Okay, negative 1 maps onto 2, and it maps onto 4. It maps onto 2 different things. In other words, the x value repeats. This would not be a function, not a function. But this is a function. So that'd be yes. Okay, let's go down here. There's a couple more. Okay. We got another mapping here. Look at D first. Negative 2 maps onto negative 2. one maps onto 0. But here we have 2 mapping onto 2, 2, 2, and we also have 2 mapping onto 3. So right here, I have 2 x values that are the same. This would not be a function. Okay? Here, we have a graph. There's a ton of ordered pairs. This curve represents infinite amount of ordered pairs. So it is a relation. We're going to use the vertical line test on this. And I can see right here, it intersects the graph at 2 different points. Well, this x value and this x value are the same. So this is not a function. It doesn't pass the vertical line test. If you continue on, it would not pass the vertical line test here. So this is not a function. So how do you tell if a relation is a function? You can use the vertical line test, or you could look and see if the x values repeat or not. Okay, so example, given g of x equals 3x minus 2x squared, find the following. So we're going to evaluate functions here. Now we're working with the g function right here, and here they want us to find g of 2. What does that mean? Plug 2 in for x in your function. So g of 2, we're not solving the equation here, we're just evaluating this rule right here when we plug in 2. So it's 3 times 2 minus 2 times 2, we're plugging in for x squared. So now it's just order of operations for the most part. Okay, so we got 3 times 2 is 6, minus 2 times, we got to square this 2, which is 4. So it's 6 minus 8. In this case, 6 minus 8 is negative 2. So negative 2 is your answer. You could just leave it like that. Or you could write it as an ordered pair. We plugged in 2 for x, and g of x was equal to negative 2. That's my output. Or you can write it as an ordered pair. Okay, we're multiplying here. A lot of people multiply the 3 and the negative 1 and plug that in. That's wrong. We're going to multiply these two answers. I got to find g of 3, and then I got to find g of negative 1. And then once I get those two answers, then I would multiply them. So first of all, let's find g of 3. Okay, let's plug in 3. So it's 3 times x, which is 3 now, minus 2 times 3 squared. 3 times 3 is 9, minus 2 times 3 squared is also 9. Order of operations, I'm going to multiply before I subtract. 2 times 9 is 18. So this is equal to negative 9. That's what g of 3 equals. Then, let's move this down a little bit. Let's find g of negative 1. Okay, so 3 times negative 1 minus 2 times negative 1 squared. Got to be careful with these negatives a little bit. 3 times negative 1 is negative 3. Usually do exponents first, but there's subtraction in the middle there, so that's kind of my buffer zone. Negative 2 times what, though? Negative 1 squared. Negative times negative is a positive 1. So basically, this is negative 3 minus 2, because negative 2 times 1 is negative 2, so it's just negative 3 minus negative 2. This is going to be g of negative 1 equals negative 5. So what do I do up here? Okay, here's what I do. I know g of 3 equals negative 9 times, I know g of 1 equals negative 5. Then I multiply the two. Negative 9 times negative 5, once I get my two answers, I'm going to get positive 45 for that bad boy. So that is done. Okay, what do we got over here? C. Find g of 3x. Okay, so now we're plugging in expressions too, not just numbers. So finding g of 3x, well, you just plug that in for wherever you see x over in this expression here. So it's 3 times x, but now I'm saying x is equal to 3x. Minus 2 times 3x squared. This is pretty easy. 3 times 3x. Basically 3 times 3 is 9. And that's just going to be 9x. Minus 2 times, okay, 3x squared. 3 squared is 9, first of all, right here. and x squared, well, that's x squared. X times x is x squared. So it ends up being this, 9x minus 2 times 9x squared, that's negative 18x squared. This would be my answer. You could write it as an ordered pair, but generally we don't write this as an ordered pair. This expression is my answer for this particular problem. Okay. So here we got 4 functions. We're going to be evaluating the following expressions given the functions. So you got to kind of differentiate and see what you're actually working with here. Okay? So let me see if I can get this going again. There we go. First of all, A, they want us to find g of 10. So I'm working with this function right here. There's 4 different functions. You got to decide which one you're working with. If they put g there, you're working with the g of x function. So g of 10 is negative 3 times x, which in this case is now 10, plus 1. Negative 30 plus 1, well that's negative 29. That's your answer. You could write it as an ordered pair. Once again, x was your input, so that's 10. Your output, which is g of x, or y, is negative 29. Okay? Oh. B, f of 3. Well, here's my f function right here. So f of 3 is going to be using this rule, plugging it in for x, 3 squared plus 7. So this is 9 plus 7, or 16. So 16 is my answer. Let's see what we got over here. Okay. Just h of negative 2, fine. Here's my h function. So h of negative 2 equals, well, that's 12 over x, or 12 over, in this case, negative 2. There's my x right there that I'm plugging it in for. 12 divided by negative 2 is negative 6. So negative 6 would be my answer. If I wanted to write it as an ordered pair, negative 2, negative 6 would be my ordered pair. Okay. Plugging something into the j function, j of 7. The rule for j of x is 2x plus 9, so this would be j of 7 equals 2 times, I'm plugging in 7 for x, plus 9. So 14 plus 9, or just 23. That's my output. H of a, this is pretty simple. Some people get kind of weirded out because it's a different variable or a variable term. Hey, if we're going to find h of a, that just means we're going to plug in a wherever you see x in your function. So right here, this is 12 over x, but in this case, we're plugging in a. So basically, it's just 12 over a. Just an expression. It's not just a number. It contains a variable, so it's going to keep that variable. Okay, g of b plus c. So wherever I see x in the g of x function, I'm going to plug b plus c. Where's g of x? Right here at the beginning. So if I was going to write it, I'd write g of b plus c equals, plugging this in for x now, negative 3 times b plus c plus 1. So just simplify it, and that's your output. Distributing this negative 3, I get negative 3b minus 3c plus 1. And that's it. We didn't have to square anything. Just distribute and then simplify. I can't combine either one of these terms, so I'd leave it as that, negative 3b minus 3c plus 1. Okay, this is a little bit different now. They're saying your output is 16. They say find x if g of x equals 16. So first of all, we're working with this function up here. And they're saying your output is 16. Well, here's the rule to find your output. So you're going to replace g of x with that negative 3x plus 1 and just set it equal to 16 and solve. And if you solve this for x, that'll be your x value. So subtracting 1 from both sides, negative 3x equals 15. Divide both sides by negative 3. X equals negative 5. Now what does that mean? Well, when x is negative 5, your output is 16. So you could write it as an ordered pair like that. But they just wanted us to find x, so that's my answer there. X equals negative 5. What do we got over here? h of x equals negative 2, find x. So once again, we're looking for x, not our output. So we're going to use our output to find x. The rule for h of x is 12 over x. So if my output is equal to negative 2, 12 over x equals negative 2 then. And I can solve this now. I don't want a fraction, so I'm going to multiply both sides by x over 1 or just x. It's the same thing. These x's cancel out. 12 equals negative 2x. And then just divide both sides by negative 2 to cancel that out. X equals negative 6. So we found that one. X equals negative 6. Let me move this down a little bit here. They want you to find j of x. Actually, they want you to find x when j of x equals 9. So you can use this j function over here. I'm going to let you try it. Your answer should be x equals 0. So try it on your own, see if you get that answer. If you don't, you can come and ask me questions tomorrow in class, or in class right now. Okay, last problem, example 4 here. Here's where we kind of apply some of this function notation to a word problem. Swine flu is attacking Porkopolis. The function below may be used to determine how many people have swine flu, where t is time. So instead of x, we're going to use t because t is time. That's perfect. S is the number of people in thousands. That's how many people would have the swine flu. Remember, S of t is like y, but in this case, we're just going to use s. So, find S of 4. Now, what that means is time. Plugging that 4 in for t, which is time, 4 days. So, S of 4 equals, using this function right here that they're talking about, S of t equals 9t minus 4. 9 times 4 for time, 4 days. Minus 4. So this is 36 minus 4. This is 32. Equals 32. Now what does that 32 really mean? Now that's people in thousands. Okay? So what does S of 4 mean? Well, the 4 is 4 days. Okay? And after 4 days, 32,000 people, because it's in thousands, so 32 multiplied by 1,000, 32,000 people have swine flu. So that's a lot of people after 4 days. So it's moving rapidly. Okay, we did a little bit of this with the last problem. Find t now. They want us to find how many days it takes, not 23 people, but 23,000 people to get swine flu. But we're just going to use 23 right now because S is in thousands of people. So what is S of t equal to? 9t minus 4, that's your rule. And whenever you plug that time in, we're going to get 23 out. So basically we're solving this equation. If I add 4 to both sides, I'm going to get 9t equals 27. If we divide both sides by 9, we get t equals 3. Okay, so we found t is 3. So what does S of t equals 23 mean? Well, t equals 3, so after 3 days, okay, 23,000 people have swine flu. Okay, so that's what S of t equals 23 means for this particular problem. It says graph the function. Okay. The way I'd look at this is basically S of t is kind of like your y equals 9t minus 4. T is kind of like your x. So if I'm graphing this, it's in slope-intercept form, y equals mx plus b form. But I'm going to put a little t there because this is now the t-axis. And this is the y-axis or the S of t-axis, whichever way you want to look at it. But first of all, my y-intercept's negative 4 right here. And m represents your slope. It's going up 9 people per day, basically. So my slope is 9 or 9 over 1. So up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. Kind of like that. Or down 6, 7, 8, 9. It's off the graph, so it's not perfect. But here's my line. That's the line that represents that function. It's going up very quickly, extremely fast. 9 people, or 9,000 people, I guess, per day. And that's pretty much it. If you have any questions, let me know. Come up and see me. Otherwise, we're finished with this. You can start working on the worksheet. Peace out, Boy Scout.